Good afternoon, everyone. I know I'm standing between you and lunch, but I have about 15 minutes to cover a different topic that we haven't discussed since morning. It's about role of flash in a data center. Flash is an important aspect of both server and storage part, and Sandisk, as you know, as a memory company, is a flash memory company. Perhaps you have seen Sandisk more as a consumer or retail flash products in terms of USB flash drives, micro SD cards or camera flash cards. I like to share a little bit about the enterprise storage role of flash that Sandisk has been doing. So we have been hearing since morning there's an exponential growth of data in this world. So the forecast talks about 2020 something like 40,000 exabytes of data that's coming up. Some of these numbers beyond petabytes are even hard to comprehend. The amount of zeros that you have to put in front of these is humongous. Anywhere from forecast talks about 50 to 75 billion devices, mobile devices that will be floating in the world in form of Internet of Things, mobile devices, tablets, laptops, etc. A number of photos being uploaded to the social networks every day, again running into billions of pictures, and we ourselves are doing it every day. And 30% of the notebooks that are going to come out by 2017 will use form of flash for storage, which is solid state drives and not really the rotating hard disk drives. So as I said, Sandisk as a consumer flash storage supplier is well known, but what I'm focusing today is more about the enterprise and hyperscale type of data center solutions that we provide. So why flash? Why flash transformed in the data center? Flash plays a critical role, especially when you're running critical workloads in your application, whether it's server or on the storage side. Flash provides you much higher IOPS. In terms of energy conservation, it is definitely taking much lower space, much lower power consumption, so your cooling requirements go down, and that overall brings down your total cost of running, whether it's acquisition or running. Also, it cuts down your capex and opex operations because of space, power, cooling, etc. So it is definitely a trend that I'm sure you're seeing who are running the data center operations. And there are some of the other factors that I like to share. So the processor or the computing power that you see in server or computers today is coming from the microprocessor, which is a semiconductor device that follows something called Moore's law that was started by Intel founder Gordon Moore. What this law says is that computing power of chips or the number of transistors on any microprocessor will typically double every 18 months or 1.5 years. Law has been holding true till now for last 20-25 years. But the storage device, which is hard disk drive traditionally in the storage and server inside, is not a semiconductor device, and it's not following the curve that is followed by the microprocessor or semiconductor device. So the performance gap between the storage device and the computing device is widening day by day, and that's causing the I/O bottlenecks. And when you use flash memory, which is again a semiconductor device following the same Moore's law curve, it can align the performance of compute with the storage, thereby narrowing that gap and removing the legacy storage I/O bottleneck. And this is explained on this slide again in a simple way. You have a storage, you have either a hard disk drive and flash, and the CPU utilization that you do depends on how quickly you can get the data from your storage side, and that's the bottleneck that is removed by flash. And latency as well as IOPS matters, especially when your scale of operation, your scale of database goes up. And this impacts severely to many customers. There are some examples written on this slide. In interest of time, I'll be skipping many of the information that's written there. I'll be sharing slides with you guys. Now, what are the other needs inspiring flash in the data center? Instant access. This morning, I think many speakers talked about real-time information, real-time data availability. If you have bottlenecks in your IOPS, then how do you get the instant information? And this is again linked to the memory speed performance in your computing and storage devices. In terms of economics, it supports the reducing in the cost. Also, it supports reduction in the cost in terms of power cooling, Floor space, number of racks, because much more denser now, and I'll be sharing a little bit more how it is denser. So here I put some data comparing any manufacturers. It's not specific to our company. Any manufacturer's flash-based solid-state data versus hard disk drive here. So in terms of IOPS, there's a huge gap there. 100 to 300 IOPS are offered by a typical hard disk drive. Again, there's a variety there in the market, so it's not specific to any model, but very generic. And a SSD, enterprise-grade SAS SSD, can offer in excess of 100,000 IOPS. So you can see the scale of IOPS there. Similarly, the reliability. There's something mechanical here, which is rotating drive, and then obviously it's prone to failures after certain years of operation. But SSD is a solid-state device, so it's much more reliable in terms of the mean time between failures. MTBF is much higher, failure rates are much lower. Power efficiency, another point. Depending on type of device we are comparing, the power efficiency with this flash-based drives could be anywhere less power consumption compared to hard disk drive, anywhere from 50% to 80%. So that's a drastic improvement. And also the densities in storage. When you go to the enterprise-grade storage data center, you're looking for high-performance hard disk drive. You're typically using 10,000 or 15,000 RPM drives, and they're typically available at 800, 900 GB or 1 terabyte capacity max. And the flash-based SSDs are now available up to 4 terabytes. So the density is again an important point for building a data center. This morning I kept hearing about virtualization, which is again a very key trend in memory computing and companies moving to cloud. So all this is again driving transformation to data centers using more and more flash. And again, coming back to TCO, or whether you measure your cost in dollar per gigabyte of storage, or dollar per IOPS in terms of performance, or dollar per watt in terms of power consumption, flash is coming to a point where it is becoming much more economical overall. Some particular use cases, workloads, or scenarios in the real world where definitely SSDs or flash in different form, either SSD or PCI Express cards, flash is available in different form factors now, is definitely making a complete sense. First is write-intensive workloads. You could have OLTP type of workloads where it could be write-intensive, or analyzing a large amount of logs, searching things from online applications or cloud applications. Definitely where the writing speed is critical in these workloads, SSDs make definitely much more sense with much higher IOPS in terms of write. Similarly, the delays can frustrate customers which are online with your customers, and so poor customer experience. Again, the SSD makes much more sense. Low latency. There is another mixed use case, could be email in an office environment. Again, getting data in and out of system. Again, the performance and latency, it makes a solid case for flash there. And if you have read-intensive workloads, which is a good example, there could be video on demand service. Though it's a video, it's read-intensive, you're not writing, but still the consumer experience, if you're watching a movie on your cell phone off a 3G, 4G network, then again, where the data is stored, how quickly it's coming on to you. Besides the network bandwidth, the flash plays an important role in these workloads. So these are some of the use case scenarios. And traditionally, people used flash for tier 1 type of data and then put everything else in spindles or tapes. But now the type of flash which is available is configurable for different type of workloads in data center. At tier 0, where generally the RAM or DRAM is used, which is definitely very high performance even than flash. But DRAM is extremely expensive. It is 10 times more expensive than flash and consumes 20 times roughly more power than flash. So even at tier 0, there are now solutions available which are flash populated DIMM slots. Of course, it needs BIOS changes from the server vendors, and companies like us work closely with IBM, Lenovo, and several others to make these work. They provide ultra low latency and memory class performance just like RAM, and a much lower dollar for the response time and the power. At tier 1, where you're running your database or logs, definitely where you need a high IOPS and low latency, flash is the way to go. But the form factor in this case used is PCI type of flash, And there was a company that was providing these type of solutions, leading company in the world called Fusion IO, that's acquired by Sandisk, that's part of our portfolio now. At tier 2, tier 3, you could use SATA or SAS SSDs, which are where the cost is coming down dramatically year over year. So if you have to get a glimpse of various form factors of flash that are available today in the market in terms of the value, in terms of the performance and latency, you could get a SATA SSD at the cheapest price points in terms of the dollar per gigabyte, available up to, let's say, 1.6 terabyte capacity today in the market from any vendor you take. Then if you need higher performance, further higher performance, the SATA SSD will typically give you about 50,000 IOPS type of performance. Then moving on to SAS SSDs that easily replace spindles, can offer more than 100,000 IOPS and up to 4 terabyte of capacity. And the highest performance tier is these PCI Express flash SSDs. These are moving also to the NVMe standards going forward. And ultra high performance is these flash stuff DIMM cards, which are very, very new, just coming up, not even fairly well known in the market. On the capacity side, these are available up to 4 terabytes, and now going all the way up to 500 terabyte of worth of flash in a 3U form factor is a new product available from Sandisk, just announced about 2 weeks ago. So with all these capacities coming up in low form factor, your dollar per gigabyte investments are definitely going down day by day. Who would think that a flash SSD could be cheaper than hard disk drive? But it depends what your requirement is. If you're looking at high performance IOPS, then in terms of dollar per IOPS, definitely SSD is much cheaper. If you're sensitive to power consumption, where flash is much lower power consumption, your IOPS per watt SSD is much cheaper. If you're a capacity tier, your requirement is high capacity, where the SSD is available today, it's shipping 4 terabyte single SSD 2.5 inch drive. And if you think about a JBOD with 24 slots, you are talking about almost 100 terabyte in one JBOD box. So if you look at capacity tier, definitely, again, it can offer the kind of densities that are not available in 10,000 or 50,000 RPM hard disk drive. And don't have time to go through these, but if you look at the capacity, the form factor that flash can fit into compared to HDD, it definitely forms much lower dollar per IOPS based on the requirement. If you look at absolute dollars to dollar comparison of hard disk drives and flash based drives, flash is still expensive, but prices are constantly going down. Why? Flash memory is a semiconductor technology. It's going down the design nodes and the fabrication node year over year. Today, most flash companies are making chips, shipping bulk chips in 19 nanometer process and going down to 16 and 15 nanometer process. And we expect, as a company, by 2017, price points of flash-based SSDs with the hard disk drives will be very, very close. Also, certain workloads for which flash is a very good solution. One is databases, other is big data and analytics, virtualized server environment, and VDI. So I'll touch very briefly on this. On the database, especially running on the Microsoft SQL Server 2014, we tested the application performance with the flash drives versus hard disk drive, and it offers a huge performance. Similarly, on the virtualized server environment, everybody since morning is talking about the virtualization is the way to go. If you're putting SSDs there, it is definitely offering you much more virtual machines per physical server compared to using a hard disk drive. VM per machine, this data is available. I'm not going through each of the details. I can share all the data. So more VMs per host, so thereby bringing the cost of flash much lower. And some time ago, the previous speaker, Sharad, talked about a big boom on the e-commerce, and all these companies are completely building data centers, the server and storage in a different way. And their workloads are all big data analytics. That's growing. They're using things, different type of databases, whether it's Cassandra, MongoDB, and they're using different type of environments. The flash is the way to go there, and we have number of data points that I'm not showing here to show how these databases are accelerated using either a SSD or a PCI based flash. Much better performance there. And last but not the least, but also a lot of these e-commerce companies and others, new generation companies are using MySQL either from Oracle or other vendors. And traditional MySQL was written for hard disk, considering hard disk drives in mind. So the way it writes databases, when you make an update to certain pages ABC here shown in the picture, it first makes buffer copies into the DRAM or RAM, and then from RAM it writes, two copies, and thereby slowing down the performance. So at Sandisk we did this innovation called atomic writes, where using flash we are making single copy, thereby accelerating performance of MySQL dramatically. And again, a version of this software is free of charge available from us, expecting that you're using a flash there, improving the performance. This is one example. So it's not just flash or a hardware, we are also working with various workload vendors, software application vendors, database vendors to optimize performance of various databases or application to accelerate their performance around our flash. So time was limited. I'll leave my contacts with you here if you need to reach out to me or talk to me about any of these solutions around flash. Vivek.tyagi@sandisk.com, and my phone number there. I'm based out of Bangalore. We have partners based out of Bombay in the room today, available here throughout the day to talk to you, take any questions, and collaborate with you, set up any proof of concepts around flash for you to test it out and see the performance improvement. Thank you very much for your time.
Thank you, Mr. Vivek. Thank you for sharing with us. If I may say so, that flash is not just a flash in the pan. May I please request Mr. Gupchandani, please honor Mr. Vivek Tyagi with a memento. Ladies and gentlemen, thank you, Mr. Tyagi, once again. Director, Business Development, Sandisk, Vivek Tyagi. And Content Head, Times Conferences Limited, Rajesh Gupchandani.